47 or 47.5%. Okay? This helps you decide where to just limit the size of the reactor. Okay? If you look at this, you may say, oh, I want to pick 200. Okay? This is within this range, this is the point that has the largest conversion. But remember that you're going to be paying a price for the reactor. Okay? So if you see where most of the increase is, it's over this range, right? So you could actually decide to just limit your reactor size up to this point and basically save the capital cost associated with this. Because this capital cost, this extra 100 cubic feet, may not necessarily justify just a small increase in the conversion. Okay? This is what sensitivity analysis is best for. Okay? It helps guide your decision as to what is a reasonable size for the reactor to use. Okay? Obviously, we don't want a low reactor volume because this means the conversion is going to be low. Okay? All right. Any questions on this? You're totally free to pick the inputs and outputs. It really depends on you and your creativity and what you think is important. But typically for reactors, one of the key sensitivity studies you should be looking at is the effect of the design variable, which is the volume or the reactor size on conversion. Again, note something else. The trend is the conversion doesn't keep going up, right? There is a point beyond which it sort of flattens out. Why is this the case? Remember, this is a reversible reaction. So even if you keep increasing the size, you're not going to exceed the equilibrium conversion, right? There is a maximum allowable conversion. If you have an irreversible reaction, the maximum is 100%, a conversion of 1. Theoretically, you can get there if you make the reactor size big enough. But if you have a reversible reaction, okay, again, depending on the temperature and the equilibrium constant, the upper limit is usually somewhere below 1. So even if you keep increasing the reactor size, don't expect this curve to keep going up. Okay? You'll reach a point with a maximum value. Of course, if you adjust the operating temperature, you could actually force that maximum to increase or decrease. Okay? But you can't do this just by adjusting the volume. That will not work for a reversible reaction. All right, so this is an example of a sensitivity study where you investigate the effect of the design variable on some output, like the conversion. Now let's see. You want to decide on operating temperature for your reactor. Remember that the feed streams are all available at 60 degrees. And as we said yesterday, this temperature is too low. At 60 degrees, the range